What's up, math scholars? Good to be back today on a Wednesday. We're doing 10-4, day 2. We're still solving. We're still using our unit circle, so make sure you have your unit circle handy. And we did make a decision to, next week, only do 10.7 on Monday, and then basically just review the rest of the week for an open note quiz coming next Friday. So with 3 days of review, a couple study guides, speed dating, open note quiz, I feel like everybody should be aiming for an A on the next quiz, because I knew some people were feeling overwhelmed that trig is hard. Does that sound good? Who's excited about that news? So there's your unit circle. Hopefully you found it. Let's talk about the zero product property, because we have utilized it before this year, and we're going to utilize it again today. So the zero product property states if A times B equals 0, then either A equals 0 or B equals 0. Make sense? You've heard of that before, yes? Yeah. So let's recap when we've seen the zero product property in action this year. So we did factoring. We've done factoring a few times this year, all the way back to chapter 1. But we get to a point where we factor two binomials, and we know that the product of those binomials is 0. At that point, we utilize the zero product property. If this binomial times this binomial is 0, that means either x minus 2 must have been 0, or x plus 5 must have been 0. And we would come up with our solutions of 2 and negative 5. So nod your head if you remember doing the solving binomials. Remember solving binomials in that fashion? Yeah? So you didn't probably realize at the time, but that was utilizing the zero product property. Let me show you today how the zero product property will be used. Today you'll be solving trig equations, and you'll get to the point where you've got cosine x times sine x minus 1 equals 0, and you can actually use the zero product property. You've got this times this being 0, so you can conclude that one of the two must be 0. So either cosine x is 0 or sine x minus 1 is 0. Does that make sense? How that's the zero product property? And just for fun, we'll go ahead and solve this out. So grab your unit circle. We're looking for spots on the unit circle that have cosine values of 0. So there should be 2 places. 90 and 270. So pi over 2 and 3 pi over 2. And then what about over here? We would have to add this one to the other side, and then look on the unit circle for places that have sine values of 1. There's only one place, 90. Pi over 2. So pi over 2 is the answer twice. We probably don't need to include it twice. And we would include that tagline we learned about yesterday, just plus 2 pi n. Just means you can revolve yourself around the unit circle as many times as you want and still be in the same location. Okay. All right, go ahead and write down our next problem, captured straight from the textbook. It is sine cubed, yep, of x. Or I could hit the lights. Would that help? Hit the lights. Somebody want to hit the lights? All right, so this is going to be weird, but we're actually going to use factoring. If I've got sine cubed x here, and I've got a sine x here, they both have a sine x that I could factor out front, common monomial factoring. Remember doing that? So I'm going to pull a sine x out and be left with stuff inside. And that'll create that product scenario, the zero product property. So if I have sine cubed and I divide a sine out, I'll be left with a sine squared inside. And then this whole negative 4 sine x, if I remove that sine x, I'm left with a negative 4. At this point, we're ready to utilize our zero product property. Yay! We've got this term multiplying by this term and getting 0 as our answer. That's the zero product property. So we conclude that either sine x equals 0 or sine squared x minus 4 equals 0. And we'll just solve both of those. All right, so we're looking at our unit circle. We went all places that sine is 0. So all places that the y value is 0. You see anywhere? There's 2. 0 and pi. And somebody in my last class said 2 pi as well. And I'm like, well, 0 and 2 pi are the same in that place. All right, and we'll add the tagline on, plus 2 pi n. Just means we can spin around a few times and still be at the same location. And then let's head over and solve this branch. Plus 4 on both sides. Square root both sides, which gives us positive or negative 2. So go ahead and look on your unit circle for all y values of positive or negative 2. Andrew's looking. Spencer's looking. Yeah? Did you find anywhere? What, you have the answer? What is it? Right. This is undefined. You can never have a sine value that big. Spencer, you get a ticket for that. So basically there's no solution in that branch. There's no place that sine would be positive or negative 2. It's just those answers we got that. Ticket from the scholar. All right, go ahead and jot this down. We're going to talk about how to deal with if you see a cosecant. That's going to be interesting. We never saw one like this yesterday, but it's possible. So go ahead and think about cosecant. What does cosecant truly mean? Do you remember from that little tiny sheet that you taped in? It's 1 over sine. Cosecant is 1 over sine. So I got to this point and I was like, I'm trying to solve for sine x, right? Does anybody have an idea what I chose to do? Close. She said cross multiply. Super, super close. What I'm going to do, we can't cross them out because this is on an opposite side of the equal sign. But what we can do is multiply both sides by sine x. That will cancel it out. So I'm multiplying both sides by sine x. That gives me a 1 on the right and a 2 sine squared x on the left. Because there's a sine x and another sine x, so I made it sine squared x. Hopefully that makes sense, yeah?
Why wouldn't those two cancel?
Because they're both in the numerator. You can only cancel people when one's in the numerator, one's in the denominator. And we're solving for sine x. At this point, it's pretty easy. We divide both sides by 2. Get sine squared x equals 1/2. Square root both sides. That gives me a positive or negative. The square root of 1 is 1, and the square root of 2 is just radical 2. So that is where, I don't know if you paid attention during the warm-up. During the warm-up, I had like this blue circle, and I wrote, please take note that 1 over radical 2 is the same thing as radical 2 over 2. 1 has just been rationalized. They have the same value. They're both 0.77. So what we actually want to be looking for on the unit circle right now is places that have sign values of positive or negative radical 2 over 2. So I think there's going to be 4 places. Sign values of positive or negative radical 2 over 2. Oh wait, time out. Time out. There's not going to be 4 places. Look at this. Look at that guy. We are only going to be looking on the unit circle between 0 and pi. So instead of being 4 answers, there's only going to be 2 answers. It's at 45 degrees, so pi over 4, and at 135 degrees, so 3 pi over 4. Okay? All right, this is our last one. They did say we're only solving it in the interval 0 to 2 pi, so we're only doing the first trip around the unit circle. Looking in those first 4 quadrants only. On this one, I would probably start myself off by just getting all my signs onto one side together. So I would subtract this sign over to join this sign. So I will have on the left-hand side 2 sine cubed x minus sine x. Any ideas at this point? It's real similar to the one we started today with. Not divide by 2. We will divide by 2 in a few minutes, though. Yeah? No. Because this is a cubed and this is a single. What we can do is pull out and divide out front a sine x. So that would leave me 2 sine squared x minus 1. If you pull the sine x, you will have a negative 1 left right there. So be careful of that. And we get to utilize the zero product property. Yay! Awesome. All right. So either sine x is 0 or 2 sine squared x minus 1 is 0. That's a little more complex to solve. So we're really looking on our first trip around the unit circle. Where are sine values 0? At 0 and pi. I guess we should include 2 pi as well, because that would live in that interval. So 0, pi, and 2 pi. Those are where sine equals 0, so where y equals 0. There's 2 places, but this place and this place are the same place, but I'm listing them twice because they both are in the interval. Does that make sense? Yeah, this is the same location as this. All right, and so those are definitely answers. Let's head over here. We'll do a +1 to start it. We finally get to do that divide by 2 idea that people have. Or divide by 2. That gives me sine squared, so I still have to do a square root. It's going to be super similar to the problem that we just finished. It's positive or negative 1 over radical 2. So just keep in mind, 1 over radical 2 is the same thing as radical 2 over 2. So we're looking for all places that have sine values, positive or negative radical 2 over 2. And I think now there is going to be 4 places. Pi over 4, 3 pi over 4. There's a lot of answers to this one. 5 pi over 4, and 7 pi over 4. So yeah, sometimes there's a ton of answers. That makes 7 answers for this. Yikes. Okay. All right, we're done, and you have that worksheet, right, for your final answer? Okay. Thanks for watching the video.